In this video, I'm going to take a look at the homework that you did for section 5.5 on z-scores. The first question I'm going to look at is number 14. In a population, 50% of the adults are taller than 180 centimeters and 10% are taller than 200 centimeters. Determine the mean height and the standard deviation for this population. Now, this seems like a fairly straightforward question, but actually it's deceptively unusual because it's asking you for two unknown things. They're asking you for the mean and they're asking you for the standard deviation. So the fact that it's asking for those two means that there is something slightly out of the ordinary about this question. So go back to the first piece of information for a minute, where it says that 50% of the adults are taller than 180 centimeters. Let me just look up my solutions. If 50% are taller than 180, that means 50% are shorter than 180. And in fact, that means this number is right in the middle. And of course, we call the middle the mean. So, what they want you to conclude from that piece of information is that 180 centimeters is the mean. Now, the second bit of information they give you is that 10% are taller than 200 centimeters. So be careful of that because what they're telling you is 10% are taller. But if we're going to be able to use our z-score tables and locate this probability, we need to know what is on the left of that line. So, if 10% is on the right, then 90% is on the left. And the probability that we're going to be looking for is zero 0.9 on our table. So let's take a look at the table. So remember, you're looking for the probability in the center. These are the z-scores in the columns on the left of each one, and these probabilities are the ones we're looking for. So we scroll through. I usually look at the first column. I'm seeing down to 0.5 there. So then I go over to this column. All right, finally, I'm seeing 0.9. Now, if I take a look at this one, I want to find 0.9000. So I go scrolling along and I realize, okay, well, I'm getting close right here. I'm only 3 points away, whereas for this one, I'm 15 points away. Looks like my actual probability is right here, 89.97. And so we now know, sorry, I forgot to get the z-score from that as well. So it was 89.97. So that is 1.2. And then we're going to use 8. So 1.28 is the z-score. Once you have the z-score, we should be able to find the rest of it fairly easily. We need to find the standard deviation. Our z-score, 1.28. The actual value that we're working with right here was 200 minus the mean, and now we have a chance of finding the standard deviation. Multiply by 1.28 on both sides, multiply both sides by theta or the standard deviation first, and then divide by 1.28, and we get a number of 15.625. So the mean is 180 centimeters, and the standard deviation is 15 point, and I rounded it to 2 decimal places, 63. Next question that people asked about that had a fair amount of information in it would be, let me just see where we are. It's number 19. This one talks, and it gives you an information actually at the beginning. It says in the insurance industry, standard deviation is used to quantify risk. And here's an important statement. The greater the risk, the higher the standard deviation. Just something to store in your mind. If it's a high standard deviation, the risk is higher. So then they did some examples. And what they did was they're considering the cost of a car accident for two different cars. One is a luxury car and one is a mid-price car. Now, the expected cost of repairs for both cars is either one is $2,500. However, the standard deviation for the high-priced car is 1,000 and for the mid-priced is 400. And so then they ask us to look at what's the probability that the repairs might actually cost more than 3,000. And they give us some numbers, but let's go ahead and use these numbers and see if we can come up with some answers. So we're looking at number 19. Okay, first of all, greater the risk, higher the standard deviation. Now you have your luxury car. You know that repair is going to be 2,500, but your standard deviation is 1,000. Okay, this is just the information from the question itself. And the mid-price car, also a repair of 2,500, but a standard deviation of 400. So what we're going to do is take a look at what the z-scores look like for these guys. Z is equal to x minus the mean divided by the standard deviation. So what we want to know is what is the probability of it being $3,000 or more? So we put 3,000 minus the mean divided by 1,000, we get 0.5. Do the same thing for the mid-size car. This one has a standard deviation of 400, and we get a z-score of 1.25. When I look at the percentages, I get 69.15 because if you look at this, a z-score of 0.5 would be over here, and so it's going to be right here. 0.5 is 69.15. And then if I did the next one, which was 1.25, that will be 1.2, and I'm going to go across until 5, so it's 89.44. Now, what you need to realize with this one is that when we get these probabilities, this is to the left. We're looking at the probability of the data to the left of the z-score, to the left. But if we're talking about that it costs more than 3,000, then what we're really interested in is the probability to the right. And we find that by subtracting by from 1,000. So we get 31% to the right for the luxury car and only 11% to the right for the mid-sized car, which is exactly like what they said. It's more of a risk the higher the standard deviation. And one other thing, just to look at it, if you look at these two equations right here and right here, you can see that they're exactly the same, except for the standard deviation. And the standard deviation was a significant difference for us to these percentages and therefore the risk, which makes a lot of sense actually. If it's a luxury vehicle, you know that it's expensive to repair. It's much more likely that it will cost a lot more than it would had it been a mid-sized car that had been injured or damaged in the same way. Okay. And other than that, I think you should be pretty good with the questions. Please take a look at each one of them, though. There are a lot of fairly standard ones in there, and make sure that you've had a chance to understand what they are asking you to find and how you would go about finding them. Okay, take care, everybody.